Good afternoon, everyone. So today, my talk is about network evolutions towards 6G. So, since this workshop is related to security, so in addition to the introduction of network evolution, I will also talk about some security contents from the 5G network. Okay, so I will start from the first G, but here I will just quickly go through what kind of technology and the infrastructure as well as the performance we had from the first generation. Then today in this talk, I will mainly focus on the transition from 4G to 5G and from 5G to 6G. And I will also focus on the security from the 5G network. Okay, so here, based on this figure, you can see roughly each 10 years, we have one generation. So since 1980, we have first generation. Then until now, 2025, we already reached the fifth generation. Then in the first two generations, basically the cellular network is used to support a voice solution as well as some simple text. Since third generation, we start have the mobile data service. This means we can access the internet. Okay, give me 1 second. Let me enable the pointer. Okay, so then in 3G network, we have the technology is about the circuit switch. So later on, we will talk a little bit more. Then once we reach fourth generation, since based on the lesson learned from the internet, we understand that the packet switch, the internet, the packet switch infrastructure was much better. So in fourth generation, we try to transform the cellular infrastructure to the packet switch infrastructure. Okay, so in order to transform the infrastructure to the packet switch, then we need to convert some technologies which originally supported by the circuit switch to the packet switch network. So that would be the voice solution. Before we use the circuit switch voice solution, then in 4G, we use the VoIP-like technology to support the voice solution, so that we have the VoLTE, voice over LTE, and the VO Wi-Fi, voice over Wi-Fi. And in fifth generation, we have the VoNR, voice over new radio. So although they have different names, but the major component supporting this voice solution is one component which is called IMS, which stands for IP Multimedia Subsystem. So you can just consider this is like a VoIP server. Okay, so this is roughly the evolution about the multimedia in the cellular network. Okay, so here you can also see that for the data rate, before initially with the mobile service in 3G network, we have only 21 megabit per second. And the number here, this is considered as the total bandwidth of the base station. So once there are multiple clients connecting to the base station, then you need to divide this data rate by number of connected clients. Then to fourth generation, we can reach 100 megabit per second, then 20 gigabit per second in fifth generation, and then it can be above 1 terabit per second in the 6G in the future. So for the latency, you can also see it can achieve ultra low latency as low as 1 millisecond. so that it can support some some services which cannot fail, or it can need to support ultra low reliability or low latency. For example, the vehicle V2X network, okay, or some machine-to-machine communication in the smart factory. Okay, so roughly this would be the network evolution towards 6G. So in the following slides, I will use a method to show how they evolve in the history, then how we will see in the future. So here you can see basically there are two momentums. One is the application. For example, we need to have the high quality of voice solution so that we have the VoLTE. So this is kind of a momentum derived from the application. For example, nowadays we require the smart factory to enable robotics to do some automation. So this is how we require the ultra low latency from the cellular network. Okay, so this is the application part. And on the other hand, we have the radio technology. Without some advanced radio technology, actually we are not able to achieve such different kinds of performance metrics. For example, low latency, very high throughput. So to achieve the very high throughput, we use the MIMO, okay? And to achieve the ultra low latency, in addition to MIMO, we also need to have a fine-grained scheduling, okay? So based on these two momentums, then we move the cellular network towards different kind of generation from 1st-G to 6G. Okay, so let's start with the evolution from 3rd generation to the 4th generation. So for the technology part, in 3rd generation, we had WCDMA. Based on this technology, we can achieve 14.4 megabit per second. So at that time, we have only small bandwidth with only 5 megahertz. Then when we evolve to 4th generation, we have the OFDMA. Okay, so based on this technology, we can have wider bandwidth up to 20 megahertz, so that we can achieve higher throughput up to 1 gigabit per second. So based on this technology advance, then on the other hand, we also have some demand from applications. Like I just mentioned, the high quality voice and the video calls. And moreover, we need to have some rich multimedia services. For example, high quality of videos from the YouTube, from Netflix. Okay, this kind of rich multimedia applications. So based on this demand, actually the circuit switch, this is not that flexible and possible to support this kind of multimedia services. This is because in the circuit switch, you may know that we need to reserve one resource for each call or each session. So this is not flexible. And moreover, the resource may be wasted because maybe you reserve a large amount of resource for a call, for the high quality voice session, but maybe this session may not consume such amount of resource. For example, we may encounter some silence, okay, in the call. So those silent period will not consume resource. Then based on this example, you can see the circuit switch is not that flexible and may waste resource. And moreover, it inherently cannot support some more complex codec, so that it cannot support the high quality voice solutions. Okay, so this is why for the transition from 3G to 4G, it involves to a fully IP-based architecture. This is based on the lesson learned from the internet. the IP can provide more flexibility infrastructure and scheduling and support. Okay, and for sure, based on these fully IP-based architecture, some protocols, especially for security, need to be redesigned. Okay, so that it can be suited for the IP-based architecture. So before, in 3G network, we already have the fundamental AAA and transmission protection with the encryption and the integrity protection. So here, in 4G network, we still use the packet switch IP for data service. This does not change. But the thing we change in 4G network is the multimedia services. For example, VoLTE and the VO Wi-Fi. So this would be the new areas we need to have a new security method. So this is why around 2010, okay, in 2010, this transition just begins. So actually, we can find many kind of vulnerabilities from these new multimedia services. This is because during the transition, the operators or standards still use the traditional method to secure these services, but actually, the services themselves become different. So this is why the traditional security method cannot work. Then this is why we can find many vulnerabilities from this area. Okay, and next, let's talk about the network evolution from 4G to 5G. Okay, in 4G network, as we just mentioned, we have the OFDMA. Then the transmission speed can achieve up to 1 gigabit per second. And in 5G cellular, we have flexible numerology. So this numerology means we can have more fine-grained scheduling. Before, we schedule the packet every 1 millisecond. But for 5G network, we are able to schedule the traffic every 1/8. Okay, 1/8 millisecond. So this means we are able to use this fine-grained scheduling to achieve a 1 millisecond latency requirement. Okay. So, and the next is the beamforming enable of DMA. So this means based on multiple antenna element, we are able to form multiple beams to transmit data to multiple clients simultaneously. Okay, so it can be more efficient and low latency. And moreover, it has the sub 6 gigahertz and the millimeter wave. Although millimeter wave, the signal may be blocked by some blockage, by some obstacles, but it can achieve very high throughput, very high data rate. And moreover, for the 5G network, we have larger bandwidth with 400 megahertz, so it can achieve up to 20 gigabit per second. Okay, so for the application, before we only allow the users to access mobile data service with some application on the internet. But in 5G network, we aim to support more performance demanding scenarios, including enhanced mobile broadband. In this area, we want to achieve much higher throughput than 4G network. And the second one is the mission critical control, like the V2X, okay? And the third one is the massive IoT, because if we want to monitor the environment or we want to have some digital twin scenarios, for sure we need to deploy a large of sensors to monitor the conditions, monitor the environment conditions or states, so that we can get some data from the environment and have some reaction to the environment. Okay, so this is a figure to show the three major scenarios we want to support in 5G network. So as I just mentioned, for the enhanced mobile broadband, we want to achieve the extreme data rate, okay? But we also want to achieve the extreme capacity and the deep awareness. And for the mission critical control, in addition to ultra high reliability like the V2X, we also want to have a strong security over some health equipment, government, or financial trusted environment. And we also want to achieve the ultra low latency, especially in, for example, the V2X, because you can imagine if one car accident happens, we would like to let this information immediately sent to the vehicles around this area. Okay, and we also want to achieve the extreme user mobility. This is like nowadays you can see that once you are on a high-speed train, actually the network will suck. Okay, so this is because current cellular infrastructure is not able to support that high speed. But for the 5G network, we expect that we can support the speed up to 500 kilometers per hour. So then if we have this real 5G network infrastructure, we can have a good network quality on the high-speed chain. And the third goal is the massive IoT. So here, the major, the most important thing is try to have the ultra low energy design and the ultra low complexity. So these IoT devices different from the smartphone we are using, okay? Because we would like to let the IoT devices to sustain for maybe more than 10 years. So its operation need to be very energy saving, so that we do not need to replace the battery frequently. Then it can sustain for several years, maybe up to more than 10 years. Then we need to reduce the complexity of the modem on the device, and moreover, its operation need to be very energy saving, so that its battery can support this kind of long life scenarios. Okay, so for the network evolution from 4G to 5G, in 4G network, we have the fully IP-based architecture, and it's primarily hardware-based and static. And its security is centralized and the implicit trust in core. So for the 4G network, if you are doing research, or if you conducted research in cellular network, you may know that before, it is difficult to get the 4G core network. All the 4G core network are closed. Okay, this is like a black box. Okay, so hidden from the vendor, for example, the Nokia or Ericsson. Okay, so you would not know how they design and implement the core networks. Okay, even for the operator, they would not, they don't know either. Okay, so in 5G network, we would like to make the whole architecture more flexible. The reason is that, as we just saw, we need to support different kind of scenarios, devices, and the environment. So without flexible architecture, it will be difficult to achieve these diverse goals. So in 4G network, we want to have a service-based architecture, virtualized, cloud native. So different kind of services, network functions can be deployed in the core network based on this virtualization. And also, different kind of services have different performance requirements. So we will use the network slicing to provide multiple slices for different services using the same architecture. And moreover, we want to have the dynamic scaling. So once the traffic demands increased suddenly, then we can scale the capacity dynamically, and also the edge computing to achieve the low latency. Okay, and the third, we want to have the unified network architecture which can cover non-3GPP access, because in the 5G era, actually, the standard community is quite ambitious. They want to integrate all the network access, including the non-3GPP access, including Wi-Fi, cable, and any other kind of wireless access. Okay, and for sure, based on these new features, functions, we need to have a new security method. Before, this is fully centralized. This is like a black box, and we always trust the code. But once we make it more flexible and we allow the third party to develop some applications, then here we need to have our security design need to be able to secure the distributed function in the core network. Then also the service-based architecture, and also we may want to achieve the zero trust infrastructure in the core network. Okay, so based on the features we introduced here, we want it more flexible, and we want to allow the third-party application to deploy their innovative application or services in the core network. So here in 5G era, we embrace the open and the programmable infrastructure. So it breaks away from traditional closed mobile systems. And based on this open and the programmable infrastructure, we have more new and promising application scenarios. For example, the major scenario would be the private 5G network. Okay, so the private 5G network can provide an exclusive use of an organization or enterprise. Okay, for example, today, one company, for example, the TSMC, they want to enable the automation in the factory. Based on the factory automation, we may need to achieve the ultra low latency below 1 millisecond. Okay, so for this kind of scenario, it is difficult to use public operator to support this kind of scenario. Okay, because they may encounter very long propagation delay. Okay, when the traffic go to the internet, then the delay would be much longer and unexpected. So they will want to deploy their private 5G network. Okay, try to deploy the core network in their factory, and moreover some edge services on the next to the core network and the next to the end devices. So this would be the major point of the private 5G network. Okay, one company can own a complete 5G network to support their applications. So telecom market has been changing due to this kind of private 5G network scenario. It's break monopolization of traditional vendors, for example, Ericsson, Nokia, and Huawei. So there are more non-traditional vendors joining the ecosystem, because in 5G network, this is cloud native. So you just need to have a traditional server, then deploy some virtualization platform. Actually, you can build a 5G core network. And you can also buy the Wi-Fi access point using the non-3GPP protocols, so that the smart factory can be deployed for the support of the private 5G network for this scenario can be deployed. Okay. So there are a lot of opportunities from open and the programmable 5G infrastructure, because the core networks are open, and moreover, nowadays the Open RAN is also developing. Okay, so here is the number from a survey for the private 5G network market. So here you can see we are here. Okay, 2025. This is around. Okay, this is I think this is around 4 to 5 billion. Then until 2030, we expect that the private 5G network market will achieve up to 36 billion. Okay. And here you can also see that commercial 5G core network proliferate. Okay. In addition to the traditional core network vendors, Nokia, Ericsson. Now you can also see we have Savia. Savia is the business version of free 5GC, and Ethernet Core, Kumu Core, Casal Systems, and Taiya. This is also one vendor from Taiwan, or Zhuid. Okay, so you can see there are so many core network vendors appear when the 5G network, 5G standards was proposed. And here you can also see that for our research community, we can also have many choices for the 5G core network, including free 5GC, open 5GS, open air, and so on. So free 5GC actually is the platform we are developing. So our team is trying to develop the most important security functions in free 5GC. So here you can see the free 5GC already support the function up to release 17. Okay, so here is the roadmap of the free 5GC release. Then you can also see the free 5GC has been adopted widely, including many companies here. For example, Zhonghua Telecom, Fujitsu, HCL Tech, H-Core, and so on. So you may wonder that why Zhonghua Telecom still need to use the free 5GC? Why not just use the commercial 5G core network from Nokia or Ericsson? This is because they still need to do some functional testing or try to develop some new functions. Then maybe for from the Nokia or Ericsson, the 5G core network is still like the black box, or it would be difficult to allow the operator to do some testing or research. So they still need to have this kind of open source version to do some research and testing here. Okay, so here are the free 5GC download statistics for your reference. So here just want to show that free 5GC actually is one popular core network for us to conduct the research. Especially it already includes many important security functions. Okay, so after introduction, the evolution from 4G to 5G and some major technology of 5G network, then here I'm going to talk a little bit about the 5G security. So here are four major aspects I'm going to cover. So including the design principles, subscriber and the device protection. Okay, so this is about the end device. Then I will also talk about the protection over the infrastructure or the network. And I will also point out what will be the new network technologies and the threats. Okay, so here are three major secure design principles. The first one is the use of mutual authentication. So you may know that actually in the second generation, we do not have the mutual authentication. We only have the one-way authentication. This is the core network will authenticate the end devices. So this is why nowadays we still have the ROC base station. Okay, because the attacker can try to use some signal spamming, let the device downgrade the device generation until the down to the second generation, so that the device can be spoofed by can be fooled by the infrastructure. Okay, because in second generation we only have the one-way authentication. Okay, since the third generation we have the mutual authentication. So in 5G network we still follow this design principle. Okay, the sender, the end device, and the core network need to authenticate with each other. But in the 5G network, actually we have three kinds of authentication method. One is the 5G AKA, which follows the 4G, original 4G authentication. Okay, and the second is the EAP AKA, EAP should be the EAP AKA prong, and the third is EAP TLS. So these three are used for different kinds of scenarios. As we mentioned before, since we need to support such different kinds of devices. For example, for some devices, they may not have SIM card. So the EAP TLS authentication method is proposed to support the device without SIM card. Instead, they can use the certificate for the authentication. Okay, so this is about the mutual authentication. And the second, we have a presumed open network. So since this network is quite open, we allow the third-party vendor to deploy some services or application. So we should have a stronger security protection, so that we need to have the complete mediation. So we try to remove any assumption of safety from overlaid products or processes. For example, before, we always trust the core network, but nowadays it changes. We do not trust any network function or application. So in the core network, we always need to do the authorization and authentication, even for the network function between the network functions. Okay, and the third, an acknowledgement that all links could be tapped. So actually, these two is just try to follow the zero trust design principles. We just try to remove any assumption of safety. Okay, we always need to do the access control and authentication. And for the subscriber and the device protection, okay, so we also protect the confidentiality of the initial non-access strengthened messages between device and the network. So it can be against man in the middle and the fake base station attacks. So before, in 4G network, for the initial message, actually they are not protected. So why they are not protected? Because they do not have the security context between end device and core network in the initialization. So, but in 5G network, for this kind of initial messages have been protected. So how we protect these initial messages? This is based on PKI. Okay, so we can use the end device can use the private key of the core network to protect the initial messages. Then the core network can use their private key to decrypt these initial messages, so that it can prevent some man in the middle attack. Because before, without the protection of the initial messages, the ID and some information of end device may be leaked once the attacker eavesdrop on the wireless channel. Okay, and the second one, the home control is implemented. Okay, before, for example, let's consider a scenario. When you go to US, we have actually the network infrastructure will include two parts. One is the serving network. Okay, the other is the home network. When you go to US, then you are the subscriber of the Chunghwa Telecom. Then maybe the partner of the Chunghwa Telecom in US is AT&T. So the serving network will be the AT&T network, and the home network will be the Chunghwa Telecom. So before in 4G network, the final authentication would end at the serving network. So this means the Zhonghua Telecom does not know whether the authentication succeeds or not. So it would be difficult for the home operator to control the end devices or know the status of the end devices. So in 5G network, the security increase the home control. All the authentication procedure need to go back to the home network. Okay, so this home network can know better the status of the devices. Okay, so I show here the final device authentication to a VDT network, such as AT&T, in the example I just mentioned, is completed after the home network has checked the authentication status. So it can be against various roaming flows types. Okay, and next about the device protection, it also proposed a unified authentication across other SS network types, including wireless LAN. Okay, so this would be the non-3GPP security protocols we just mentioned. And also, it also considered the user plan integrity checking, and also provide the privacy protection using the public and the private key pairs. So in addition to the initial message, which protected by the PKI, public key and the private key, here, since the ID is also sensitive, so we also protect the ID using the public-private key pairs, okay, in 5G network. For example, when the ID in plaintext, this is called SUPI. Okay, subscriber permanent subscriber user permanent identify. And actually, the full name I'm a little bit forgot. But when we try to encrypt the SUPI, which is plaintext, then this ID is called SUSI, okay, concealed identify. So this is also based on the private and public key pairs. Okay, and next is about the network protection. So the network protection here is to consider the network, the communication between two operator networks. For example, AT&T and Zhonghua Telecom. Okay, so for each network architecture, if it want to communicate with another network, it will use this network function, which is called security edge protection proxy. Okay, so this is a security gateway between home network and the visiting networks. So this security gateway, it will use the application layer security against the eavesdropping and the replay attacks. It does not use for the hub-by-hub security protection. It may also use some, for example, transport layer security, such as TLS, or IP layer security, such as IPsec. But here, for the communication between this proxy, they use the IP layer security. This is because they will have some network provider sit between two networks. And based on this application layer security, actually this network vendor can provide some add-on services. For example, they can check the message exchange between two networks to do some anomaly detection. Okay, so this is why they want to use this application layer security, because it can provide some flexibility to let the network vendor sit between two networks to do some, especially for the security check. Okay, then based on this, the security function from SEPP can overcome the existing security risks linked to SS7 and the diameter usage. So these protocols are used by legacy cellular networks, for example, the 4G networks. Okay, and for the proto stack, since nowadays we already completely converge the cellular infrastructure to be IP-based infrastructure. So here we use the IP-based protocol stack, including HTTP, TLS, okay, and we also use the RESTful framework for the message formation. So it can allow the interoperability with many services and the technologies. It can also lead to a short vulnerability to exploitation timeline. The reason is that all these protocols have been released for a long time. Okay, and moreover, it has been public for a long time. So once there are any vulnerabilities existing in these protocols, they should have been discovered. Okay, or if there are some new vulnerabilities discovered in this protocol, actually many researchers study these protocols. They can try to fix them quickly. But the drawback is that it can expand the potential pool of attackers because these protocols are released to the public. So all the attackers can try to study whether there are any new vulnerabilities in these protocols when they are deployed in the cellular network or not. Okay, so in the following, I'm going to go through the new network technologies we currently have in 5G network, and also point out any potential threats caused by these new technologies. So the first one is the virtualization. So basically, I think the most famous one is the VMware. Okay, so all the relative vulnerabilities may happen, okay, in the core network. Okay, so for example, and this virtualization can be in the form of container-based or in the form of the VM-based. So here, in the literature, you can also find that the virtualization platform is not that secure. Okay, for example, these two works, they are published in top security conference, including Spectre and Meltdown. So basically, they show that one container or virtual machine can steal the data, okay, from another virtual machine through the shared memory. Okay, so then if you are interested, you can just search based on this keyword, then you can find this vulnerability from the virtualization. Or some vulnerability may cause the containers, okay, to be escaped when run as root. And some new technology including MANO, management and orchestration processes. So basically, virtualization technologies can enable network segmentation and the resource isolation, but we still need to have this is like the management tool, try to manage these virtualization pieces or components. So if we have a poor management function, poor MANO may nullify all these advantages. Okay, and hypervisor is kind of brain of virtualized technologies. Okay, then hypervisors may have bugs. I think if all the software may have bugs, so we may expect that there may be some vulnerabilities existing in the hypervisor. Okay, and new network technologies include cloud services, okay, and the network slicing. So cloud services, it has been used for, I think, for a long time before the 5G standard is introduced. Okay, so any kind of vulnerability which happened before may also be found in the 5G core network. And for the network slicing, basically, this is used to isolate different services. But sometimes, if it has vulnerability, different traffic or application in different slices may still affect each other. So this is also need to consider. And next one is the embedded SIM. So embedded SIM is a new feature. Actually, currently we already have. Before we use a SIM card, you need to input a SIM card onto your phone physically. But based on the eSIM, actually the SIM is embedded on your devices. Okay, so you need to download a profile into your eSIM. So this download procedure, this is based on the PKI certificate. So you can imagine, once this download platform or download service has some vulnerability, we may be able to download some others' profile onto your SIM card. So may try to abuse the services belong to other users. This is also possible. Actually, this is also the area we are studying in terms of the security. And this eSIM identified by a globally unique EID similar to a SIM card and is able to store many profiles. Then each profile is used to identify and authenticate the subscriber. And the last one is the artificial intelligence. So since in the 5G or in the future 6G network, we want to enable or deploy the AI solution so that we can automate the procedure in the core network or try to make the core network become more automatic and secure, or actually any functions can be improved, okay, automated by the AI solution. So once we deploy the AI, actually it may also contain some vulnerability. So AI, and moreover, AI-driven attacks may be anticipated. Sorry. Okay. Okay, so after the introduction of the 5G security, then let's start to talk about the transition, the evolution from 5G network to the 6G network. So for the 5G network, actually here you can see before we already have the massive MIMO. So what we can do, try to enhance the throughput, is try to increase the number of antennas. So in 6G network, we have the ultra massive MIMO. Sorry. So we have the ultra massive MIMO. We can have more than 1025 antennas. Okay. Then we still use the millimeter wave and the terahertz technology. And here the bandwidth can achieve up to 20 gigahertz, and the speed can be, the data rate can achieve more than 1 terabit per second. And moreover, I think the major technology, new technology in 6G network is the NTN integration, non-terrestrial network, including the satellite, LEO, or the UAV. Okay, and moreover, we expect that we will have the AI-driven communication. We may not have some static configuration. We can have the AI try to keep improving the performance of the core network to better serve the end devices and the different applications. So for the application, before we already had enhanced mobile broadband, mission critical control, massive IoT, and 6G, we expect that we will have the immersive XR, digital twin, massive communication, and the ubiquitous connectivity. Okay, so this key emerging application actually also define the performance demand of the 6G network. Okay, so the first one, immersive XR, before we focus on, for the multimedia, actually, we would like to have the low latency. But here, for the immersive XR, since there are some interaction, then we need to focus more on the response time and the throughput in addition to the low latency. So here, actually, we are we can, based on the survey, actually we expect that the VR market can reach 442 billion by 2030, and AR can reach 198 billion by 2030. So you can see this application is quite actually nowadays we already have some VR and AR application. In the future, we expect there will be more to provide the truly immersive interaction or application for humans. And the second is the digital twin. So it can replicate physical entities into a virtual world. So based on the digital twin, then you can use this to visualize an infrastructure. For example, before I went to an office of operator. Actually, nowadays they already use the digital twin to manage, control their core network architecture. So based on this digital twin, they are able to see when there are any issues happen in their infrastructure. Okay, so for this digital twin, actually we need to support massive IoT devices, because to support digital twin, you need to monitor all the environment and all the infrastructure components. So you need to have a large amount of sensors. And moreover, you should be able to interact with all these devices, okay, in the infrastructure. So the low latency also be expected. And the third, massive communication. So actually, the massive communication is also expected to support the digital twin. Okay, so for example, we need to a large amount of sensors, okay, to get the status of different components, and also we also need this massive communication to support the smart homes, factories, and the cities. And the last one is ubiquitous connectivity. So since we want to, for example, in 5G network, we may not be able to support the device communication on the high mountain or high building or on the sea. Okay, so we can use the satellite, the LEO, to complement the ground communication services so that it can support the sparsely populated areas such as deserts, mountains, and the seas. Okay, moreover, it can also use for the disaster and the emergencies. So the network evolution, based on the, we already saw the communication technology and also the application demand. So based on these push and the pull, then we can expect that the 5G network, this is still centralized architecture. Then we expect for the 6G, we will have an application-driven distributed architecture. Because you can imagine satellite, ground-based station, UAV, all these devices can support network access. Then they may not, this is not necessary for them to connect back to the core network. They may just go to the internet through the edge, okay, or through other network access. Okay, so we expect that we should have a flexible model of data communication. Then this is like an application-driven distributed architecture. And before, we mainly have the terrestrial network. This means we only have the ground-based station. But later on, we expect that we will have the ubiquitous connectivity with NTN. okay, we will integrate the ground-based station with the satellite, UAV, and some other kind of base stations. And third, before in 5G network, we still need to design the static algorithm to optimize the performance, support different kind of application. But in the future, we expect that we will deploy the AI solution on the 6G network infrastructure, so it can enable the autonomous optimization and the networking. So we will have a native AI integrated system. So in the 5G core network, the security, we already enable the security to support the distributed network function in core and the service-based architecture. But all these security solutions are static. They are not enabled by AI. Okay, so in 6G network, we expect that we will have a fully distributed. Okay, for example, they will deploy on the satellite, edge, core network, and UAV. According to different scenarios, then we may need to have the AI-driven solutions to adapt themselves to support well the different kind of scenarios. Okay, so when will 6G arrive? So here is the Nokia's expected timeline. Okay, just give you a sense that currently where we are in the 6G, 5G, in the evolution from 5G to 6G. So nowadays, I think we are at this point. So the should be here. Okay, at the beginning of the development of release 20. Okay, so here is still 5G advanced, but we are already trying to, the standard community is already trying to define the 6G requirement. Okay, so next year they will define, try to study the 6G technologies, and the year after next year, they will try to develop the first version of 6G spec. Okay, so here at the mid of 2028, we will have the first version of 3GPP 6G spec. Then at the end of 2029, we will have the commercial 6G deployment. Okay, so this is roughly the timeline. Then this is from the Nokia's. Okay, so finally, based on evolution, we just present. Actually, this evolution, we can clearly see that this is driven by radio technology and also shaped by application, because without the application demand from human, actually we will not need to push the performance to such to a different kind of metrics with such high standards. And 5G cellular has transformed the telecom ecosystem and the market because it becomes more open, and it can provide more opportunities for researchers and the non-traditional vendors to do research for the cellular network, and also jump to the market of the cellular network for the vendors. So 6G cellular is evolving to a new era of merging physical and the virtual worlds based on the immersive SR applications and the digital twin. And moreover, we have the ubiquitous connectivity. No matter where you go, we always have the network access. And we expect that we will have the distributed architecture with AI and NTN. So it offers vast potential for us to contribute. Okay, so I think this will be the end of my talk. So any questions?
Thanks, Professor Lee, for great talk. Any questions from the audience? Or any question from the online audience? Okay, I have actually two questions. One's about you mentioned about the open source trend in the 5G core network. Yeah, actually there will be a lot of choice for 5G core network with open source option. Yeah, and I think about security part. I think there is a debate about whether it would be more safe to have some software to be open source or not. I think one opinion is that, okay, because it's open source, so we can check if all the codes are checked out, or there will be some security threat in the code, so we can make it more secure. Another opinion is that, okay, because it's open source, so we know all the code, so I can check whether there is a problem in the code, and then I can do the attack. Yeah, I think there's still a debate in the open source community. So do you think the same argument can be applied to the 5G open source code?
Yeah, I think so, because actually I teach the computer security course. So one design principle is that in the security area, we always want to make the security protocol be open to the public, so that, for example, the AES encryption method or SHA, this kind of algorithms, they are always open to the public. So the reason is that once we open to the public, then researchers and attackers will try to study these protocols. So once a long time pass, for example, 10 years or 5 years, no one claimed that any vulnerability in these protocols, then we can consider these protocols as secure. So I think in the 5G network or the open source, once we do the open source, I think many researchers, because they want to prove their strength or prove their capability. So once they can find any vulnerabilities, they will try to report to the public. Okay, so once we open source, I think the core network can be more secure. Okay, because we can quickly get the feedback from the community, or any vulnerability, actually we can quickly fix them. Yeah.
Thank you. And another question about, you mentioned that in the 6G, for security part, it's possible that it will become some AI-driven security guarantee. Yeah. But I just wonder that when we are talking about maybe to have some security guarantee, maybe it's because the system has been examined or maybe rendered by human, and we say secure. But now it seems that maybe in the future it will be secured by AI. They say, okay, a model saying that this whole system is secure. Then how do we actually interpret this result? That, okay, how do we trust whether the result given by AI model is actually a safe result?
Actually, frankly speaking, I do not know how to claim that the security provided by AI is 100% secure. But currently, how we claim that the one protocol is secure, we will do the security analysis, or for the encryption algorithm, we can do some math to prove that. So I think how to check the protocol driven by the AI is secure, I think this is still an open research problem. So currently I do not have answers about this. Yeah.
Any other questions? If not, then let's thank Professor Lee's great talk. This also concludes today's event. Thank you very much for your participation. Thank you.
Okay, thank you.